Right, welcome to section 8.1.4. Today we're going to do a murder mystery and use some of our knowledge of exponentials and logs to help us solve this murder mystery. So I want you to take a moment and read through this script or this story, pages 11 and 12. As you read, please highlight what you think is going to be important to solve the case or any clues. All right, so as you read, hopefully you should have seen or highlighted some things. There's nothing not a whole lot of clues on the first page, just some background knowledge. The first clue I would say is the time that 008 left, 10 minutes before 2. And then he comes back at 5:05. Sergeant Faust says he talked to the doctor less than an hour ago. As the security officers are crowding into the room, 008 checked the doctor's body temperature. That temperature was 27 degrees Celsius, which is 10 degrees below normal. And then an hour has passed, and the thermometer is 24 degrees Celsius. All right, so as we go into our solving of this murder mystery, this page 13 has our the log of who signed in and out. Okay. One thing you want to take notice is that security came in at 5:12. So that initial reading of 27 degrees, or sorry, 27 degrees was when the security came in. Okay, so this was the body temp at 27 degrees. So that was the time. So when you find time of death, you are going to have to go back from that. All right, so I'm just going to set some things up for you. It says make a sketch showing the relationship between body temperature and time. What type of function is this? We talk about Newton's law of cooling, and everything cools exponentially. If you think about like a hot cup of hot chocolate or soup that you get out, it's probably really hot when you first get it out of the microwave or off the stove. Then it cools quickly, and then it gradually cools towards room temperature. So things cool exponentially, and then they cool towards room temperature. So with that being said, we're going to make a sketch. So we're going to have an asymptote, which is at room temperature, which again is 17 degrees. And then we know it's going to cool exponentially, so it's going to cool a lot in the beginning, and then cool towards room temperature. So that's our sketch. And again, this would be exponential, because things cool exponentially. And again, our equation is y equals ab to the x, and we learned that if the asymptote is not 0, in this case our asymptote is going to be room temperature, we have to put the plus k at the end. So is there an asymptote for this relationship? If so, what does it represent? Yes, of course there is. It represents room temperature. And that is 17 degrees. So I'm going to, it says use your data and the general equation y equals ab to the x plus k to write the equation that represents the temperature of the body at any given time. So we know that k is 17, and then we had the initial temperature. So we'll say x equals the number of minutes or sorry, we'll do number of hours. Sorry, number of hours. We can do number of minutes or hours. We'll do number of hours that passed since, again, it's 5:12, because that was that initial reading. All right, so our initial reading was 0:27. And then 1 hour passed, so it'd be 1:24. So just be careful, because remember, the A value is not 27 anymore due to the fact of the asymptote being 17. So make your system of equations. Remember, this is x and y, x and y. So this would be 27 equals AB to the 0 plus 17. This would be 24 equals AB to the first plus 17. Okay, so solve for, use your systems, use your knowledge of anything to the 0 power, solve for A and then B, and you'll get your equation. Then, once you know the equation to represent the doctor's body temperature, we can approximate his time of death by trying to find the last time his body temperature was normal. So if we go back into the problem, it says that initial reading of 27 degrees was 10 degrees Celsius below normal, which means normal body temperature was 37. So the last time he was alive, his body temperature was 37 degrees, and we're trying to find out when that was. So we're going to plug 37 in for y, and then solve for x. You will obviously need to use logs then, because x will be in the exponent. Once you do that, try and find out who the murderer is. Good luck. See if you get your detective badge today.